Kia ora Year 9. This video is going to go through the first 4 questions in the harder worksheet that some of us looked at on the highest common factor and the lowest common multiple. If you like this, I'll keep doing this, so let me know if it helps you understand. I'll make 4 videos, one on each row of that worksheet. So here are the first 4 questions, and they're all similar because they all want us to express numbers as the product of their prime factors. So the skill that we're working with here is using a factor tree to do that. So the first one, A1, wants us to express 204 as the product of its prime factors. So there are different ways to do this, but my favourite is to do a factor tree like this. So here's 204, and we can just pick any 2 factors. So it doesn't matter where you start. I'm going to start with 4 times 51, make up 204. Now we don't want just factors, we want prime factors. So we look at 4 and we ask, is it a prime? It's not. So we get its factors, which are 2 times 2. 2 is a prime number, so we've got there. We circle and we tick. Now 51 is also not a prime. Its factors are 3 and 17. 3 is a prime, circle tick. 17 is a prime, circle tick. So that's the first one done. But we don't want to leave it like that. We want to write it out nicely as follows. So we can write 204 is equal to 2 times 2 times 3 times 17, or we can write it in index form, which is 2 squared times 3 times 17. Right, that's question 1 done. Let's see question A2 now. Write 792 as a product of its prime factors. Exactly the same type of question, and again it says show your working clearly. You know that I always go on about that. So here's 792. Let's pick a couple of factors. Now this one I reckon it's easiest to think about 800 as being 8 times 100. This is 8 less than this, so it's going to be 8 times 99, but it doesn't matter. Right, so off we go again. 8 is not a prime, so 2 4s are 8, circle tick, and then 4 is 2 by 2, so we've got down to our prime factors, circle tick, and 9 is not a prime, but 3 times 3 gives me its prime factors. So we've circle ticked everything, and we can write 792 is equal to 2 times 2 times 2 times 3 times 3, or we can go straight to writing it in power form, 2 cubed, 2 to the power of 3, times 3 squared. Let's have a look at question 3 because it's a little bit different. One of the skills we want you to develop for problem solving is figuring out what they're asking for. So this looks a bit funny. 1400 is equal to 2 to the power of p times 5 squared times 7. 2 to the power of p times 5 squared times 7. And we have to find the value of p. So all that really means is that we can do a factor tree on 1400 and we can figure out its prime factors. And then we have to work out what the 2 in there is. Is it 2 times 2? Is it 2 times 2 times 2 times 2 times 2? In other words, find the value of this index. So let's do our factor tree on 1400. 1400, just pick any 2. So we'll do 7 and 200. 7's a prime, circle tick. 200, I'll go with 4 times 50. So this factor treeing should be feeling very easy by now, hopefully. You just need to be careful when you're writing it back in index form. So let's see what we've got. Well, 1400, and I'm going to go straight to index form here because I think you guys have probably done this often enough now, is 2 cubed times 5 squared times 7. And look what the question was asking me for. It wanted to know what was p. So we had 2 to the power of p times 5 squared times 7 is 1400, and we had to say what is p. So p is equal to 3. Okay, because if we look here, what did we find? Well, we found we had 2 times 2 times 2. So there you go. So that's that one done. Now the next one is a little bit the same. We have to figure out what they're trying to ask us to do. It's not really the doing, it's the working it out. So the fourth question is this one over here. Given that 120 is equal to this, and n, some number is 120 times 108, we have to write this number n as the product of the powers of its prime factors. So I saw some of you do this an interesting way where you worked out by hand what was 120 times 108. Now, that's not bad as a place to start. Jack did that. It's just that it's a whole lot more work than what we have to do. So you can go through and you can figure out what those two numbers times together are. But we've already been told how to write 120 as the product of its primes. So what we're going to do now is do a factor tree on 108. Then we're going to look for a smart way to times those things together. Okay, so let's do the factor tree. Well, we're told that 120, first of all, is 2 cubed times 3 times 5. And we're going to do a factor tree on 108. So we've got 4 times 27. It's a nice, easy one. So what's 108? Well, 108 is 2 squared times 3 cubed. So now let's look, without doing the whole multiplication of the big numbers, at what's 108 times 120, because that's what n is. That's what we have to find. So writing that all out, we can write 2 squared times 3 cubed times 2 cubed. Sorry about the background noise, guys. My kids are getting up for the day. There we go. So there's n, 108. So Jack, if you're watching, hopefully you're going to see this is way less work than what you did, but I know you like factor trees. Now, let's put the 2's together. We've got 2 squared times 2 cubed. Right, now let's think about how we can combine these. I'm going to write this out by hand just one time. 2 squared is 2 times 2. And then I've got 3 cubed. We're not going to do this very often because we're going to see a really cool rule that we can apply. So I'm doing all this timesing out. So have a look at that. Now, we want to write this as the product of the powers of its primes. So we're going to do index form here. We're going to say, how many lots of 2 have I got? Well, I've got 2 times 2 times 2 times 2 times 2. So that's 2 to the power of 5. I've got 3 times 3 times 3 times 3. That's 3 to the power of 4. And then I've got times 5. So we're done. Okay, we've written n as a product of its powers of its prime factors, and we've also done it in index form. So just to be clear what index form means, it's the final version that we go to after we've done this one. So this one is still writing it as the product of its prime factors. It's just longer and a bit messier. This is our favorite version in most situations. Thanks for watching. I'm going to do B1, B2, B3, B4 later on today if anyone watches this one.